Compare the domain and range as well as any intercepts, if they exist, of the functions graphed below. Write domain and range in set builder notation. Okay, so here we have our graph. Let's go ahead and find the domain and range of h of x. So first of all, h of x we can see here is a parabola. It's a quadratic, so we know that it goes from negative infinity to positive infinity, and that's our domain. Then the range is a little bit restricted. Let's go ahead and write the domain. So we have in set builder notation the set of x's such that, and then if it's all numbers like it was negative infinity to positive infinity, then it's just x in the set of real numbers. And then the range, we can see here on the graph that the lowest it goes is -4 down there at the vertex. And so we can write for h of x such that h of x, and the lowest it's going to go is -4, and then it just goes up, up, up from there. So we know it's going to be greater than or equal to -4. And then domain and range of p of x. So let's actually mark these in the graph a little bit. Get a color you can see. So here is the lowest point on the parabola, and then on g of x, then the farthest over it's going to go on the domain is -4, and the highest it's going to go is 2. And then they both keep extending. So let's go ahead and write those. So for the domain, again, the farthest it goes is -4, so we can write x. And then we know it's going to start at -4, and then it gets more and more positive going right. So we can write greater than or equal to. And then the range of that, the highest it goes is 2. So, and then it just goes lower and lower to negative infinity. So we can write it's less than or equal to 2. Notice that with inverses, again, the domain and range of the opposite function should match. And so the range and domain on the range of h of x and the domain of p of x do match, but the other side doesn't. So it's just important to note here, if we restricted this so that x was less than or equal to 2, then this would match. So let's keep going here. So the x-intercepts and y-intercepts of h of x. Let's draw these in on our graph. So for h of x, we see we have an intercept at -2, 0, and at 6, 0 on the x-axis for our x-intercepts, and then 0, -3 on the y-axis. And then for p of x, then we can look and see here that the x-intercept is -3, 0, and then the y-intercept is at 0, -2. So let's go ahead and write these up. So for the x-intercepts of h of x, we had -2, 0, 6, 0. And for the y-intercept, we had 0, -3. And then for the x-intercept of p of x, we had -3, 0. And for the y-intercept, we had 0, -2. So notice that we do have the opposite coordinate pairs for the x-intercept of h of x and the y-intercept of p of x, and vice versa with 0, -3, and -3, 0. But that 6, 0 is kind of the odd man out here. And so we again see that if we had a domain restriction where if we, starting at the vertex to -4, if we only could have our domain to the left of that going to negative infinity, so if it was negative infinity all the way to 2, then that would get rid of, that wouldn't count 6, 0, and so we see it would be an inverse function in that case. So let's go ahead and summarize our answer. The answer is the domain of h of x contains all real numbers. Written using set builder notation, this is the set of x's such that x is in the real number set. The domain of p of x, however, is restricted to the set of x's such that x is greater than or equal to 4. The range of h of x, the set of h of x such that h of x is greater than or equal to -4, is quite similar to the domain of p of x. The range of p of x is the set of p of x such that p of x is less than or equal to 2. Notice that the vertex of the parabola described by h of x is 2, -4. If the domain of h of x were restricted to only those input values less than or equal to 2, then this restricted domain would be the same as the range of p of x. The graph shows that the y-intercept of h of x is 0, -3. Notice that this is the inverse of the x-intercept of p of x, -3, 0. The x-intercepts of h of x are -2, 0, and 6, 0. One of these is the inverse of the y-intercept of p of x, 0, -2. Given what we learned when we compared the domains and ranges of these functions, it appears that p of x is the inverse of h of x with a domain restriction of negative infinity to 2.